Good morning, students. Today we are explaining about sets. Okay, first of all, what is a set? Set is a well-defined collection of objects. Set is a well-defined collection of objects, and definition should not change from your person to person. Definition should not change from your person to person. Here we have few examples for sets and non-sets. If you observe that example number 1, what it mentioned like odd natural numbers less than 10. What are the odd natural numbers less than 10? Here we have 1, 3, 5, 7, 9. So these are the numbers we have odd numbers less than 10. So it is a set and it is well defined and it should not change from a person to person. So if anyone take odd numbers less than 10, these numbers only we will have in our number system. And second example is the vowels in English alphabets. So what are the vowels in English alphabets? We have A, E, I, O, U. So these are the vowels in English alphabets. And what about the third one? So we can call the first one as set and the second one as set. And third one, if you observe the third one, the collection of difficult topics in mathematics. So how do we know what are the difficult topics in maths? So for someone, triangles would be difficult topic. For someone, algebra algebra would be difficult topic for someone. So it is varying from person to person. So that's why it is not a set. Okay. Did you understand what is a set? So set is a well defined collection of objects and definition should not change from your person to person. And next topic is representation of set. So how can we represent a set? So we denote a set as a capital letters. So set will be denoted as capital letters like A, B, C, D. So these type of capital letters. So we denote a set as a capital letters. And how can we represent? So if you observe here, A is a set of even natural numbers less than 10. So even natural numbers less than 10. What are the even natural number less than 10? We have 2, 4, 6, 8. If it is less than or equal to, then we will have 10 also here. And these brackets we are called curly brackets. A set, the elements of a set always be in a curly bracket. And the set format. So we have two types of forms of sets. So the first one is roster form or tabular form, and the second one is set builder form. So these two are the forms of set. And in between the curly braces, there will be objects or else elements or else members. We can call the these numbers or objects or elements or members who's placed between the curly braces, and this is called roster form. And if you observe this second one, it is A is equal to x is to x less than 10 and x is even natural number. Here the mentioning x is less than 10 and the condition of x is even natural number. So both are we call as sets only. So depends upon the format, depends upon the writing, and it depends upon the presentation. We call it as roster form or a tabular form, and another one is set builder form. So let me take another example of set. So if you observe this second one, b is equal to set of squares of natural numbers up to 5. So we can write it as b is equal to curly braces of 1 square comma 2 square comma 3 square comma 4 square comma 5 square. So it is the roster form of set b, and in the set builder form we will have b is equal to x is to x is equal to n square. Here they mentioning one of the formula like x is equal to n square. If you place in the if you place n value as 1, you'll get 1 square. If you place n value as 2, you'll get 2 square, like that. So they are mentioning the formula here, and the condition is n value is less than or equal to 5 and n is a natural number. This is called set builder form. So in this slide, we have covered two topics. So representation of set. So how we represent a set. So we can represent a set with the capital letters, and we have two types of forms. One is roster form and another one is set builder form. Roster form will have the mathematical representation, and the set builder form we have these type of like a statement wise form. Let's go to the next topic is elements in a set or not repeated. So if you observe this, A is equal to set of all letters of the word school. So just we have taken the word school, and it is a set of letters of A. So if you observe this set format, A is equal to, we have written SCHOL. So there are two O's in school, but we have written only one O in school because in set letters are not repeated. And the second one, order of the elements in a set is immaterial. So we can write any order. If you observe this here, A is equal to CHSOL, they have written. If we can written like this also, SOLH C also. So like this also we are able to written. Okay. There is no order of the elements in a set. Okay. Next, concept of belongs to. So concept of belongs to is like the elements of a set belongs to a set. So mathematically belongs to will be represented by this symbol. If you observe this, S is belongs to set A. That's what we have written here. S is belongs to set A. Similarly, C is belongs to set A. H is belongs to set A. O is belongs to set A. And L is belongs to set A. Every element in that set will belongs to that set only. So this is the concept of belongs to, and we represented mathematically belongs to symbol as this one. Okay, next let's go to the topic of number system. So we all know the number system previous classes of class 9th and 10th. So if you observe that the number system will have integers integers like positive, negative and 0. So if you observe that positive integers will start from 1 and negative integers will start from -1. And why we are having 0 integer? Because 0 don't have the sign, like if it is -0 or else plus 0, it will be the same. That's why it is called as 0 int. And what about the natural numbers? So natural numbers will start from 1 to infinity, and coming to whole numbers will include 0. So if you start the numbers from 0 to infinity, it is called whole numbers. Or else, if you start the numbers with +1, it is called natural numbers. And our other topic is decimals. what is decimal? So if we have p by q format, like if I have 2 by 3 as a value, I'll get the value of 1.4. Sorry, if I have 3 by 2 as a value, I'll get 1.5 as the answer. So if you observe that 1.5 will be decimal point. Okay. So we can call this 1.5 number as decimal. In the decimals, we have three types. One is terminating, second one is non-terminating and recurring. Third one is non-terminating and non-recurring. So, in the first two cases, the first case and second case, we will have the equations. We will have the number like p by q format, where q is not equal to 0 and p and q are integers. Okay. In the first two decimal things like terminating and non-terminating recurring. So what is recurring means? So it will repeated. After some point, it will be repeated like 1 2 1 2 1 2, so on will be there. And what is non-terminating and non-recurring? So it is not ending and not repeated. These type of decimals like non-terminating or non-recurring, we can call it as irrational numbers. And what are the examples for irrational numbers? Root 2, root 3, root 5, so on. These are the numbers we have in irrational things. Sorry, irrational numbers. This is what about number system. Let's go to the next topic. So we have few more notes. We need to know it. So please note it down if you want to. Okay, here are the important notes. Like the first note would be integers are also rational numbers, but rational numbers need not to be integers. So what are the integers do you know? So 2 is an integer. Okay. So what if I put 1 in the denominator? It will having a format of p by q. So if it is in the format of p by q, we can say it as rational number. That means integer able to write as rational number. What if I write 3 by 2? So 3 by 2 is a rational number but not an integer. Okay. And here are few symbols we have to denote the number systems. So what are the denotations out there? N is equal to set of natural numbers. That means 1, 2, 3, so on. And Z is set of integers. So minus infinity to plus infinity. So not equal to p by q format, like decimals are not included in integers. Integers will be exact values like -3, -2, 0, 1, 2. So these are called integers. And coming to the next one, q is equal to set of rational numbers. So any rational number, like any number in the format of p by q, we can denote it as with q. And t is set of irrational number. So we already discussed about irrational number, that is root 2, root 3, so on. These type of numbers we denote it as t. And or for set of real numbers. What is real numbers? Every number in number line would be real numbers. And W for set of whole numbers. So what is set of whole numbers? So if we add 0 to the natural numbers, then it will be set of whole numbers. That means it will start from 0, 1, 2, 3, so on. So these are all set of whole numbers. So shall we go to examples? So what are the examples do we have? Let's take one of the example. X square minus x minus 2 is equal to 0. Write it in rooster form. What is rooster form? We have already discussed it. Rooster form, that is equal to some set and values, and it will be closed. So this is the rooster form. So we have to write this equation into rooster form. For that, we need to solve it first. How can we solve it? First of all, write the equation. What's that? X square plus x minus 2 is equal to 0. So it is in the format of quadratic equation, right? How can we solve quadratic equation? We have this in the format of ax square plus bx plus c is equal to 0. So by midterm splitting method, we can find the roots of x. So roots is nothing but the values of x. So can I write this as x square plus 2x minus x minus 2 is equal to 0? So if you observe that this in the place of x, we have taken 2x minus x. So it will be same. And take the common x as common, you'll get x plus 2, and here we can take minus 1 as common, then you'll get x plus 2. So if you observe this, x plus 2 and x plus 2 will be there, so we can take x plus 2 as common. So x plus 2 into x minus 1 is equal to 0. So what will be the x values? X plus 2 is equal to 0 and x minus 1 is equal to 0. You'll get x is equal to minus 2 and x is equal to plus 1. So what are the values we have for x is equal to 1 comma minus 2? So if we write in rooster form, like a is equal to 1 comma minus 2. This is the way we have to solve the problem in rooster form. Let's go to another example in next slide. So read the question carefully. What they have asked. Write the set x is to x is a positive integer and x square is less than 40 in rooster form. So here also they are asking us to write in rooster format. So rooster format will be like this. So if you observe that what the condition they have given, x square is less than 40. So what if x values? So can I use 1? And here itself I am using x square. So 1 square would be 1. Come on. 2 square I'll get 4. 3 square I'll get 9. 4 square I'll get 16. 5 square I'll get 25. 6 square I'll get 36. 7 square I'll get 49. But they just asked us to write x square is less than 40. That means we are not considering the value exceeding the 40. So what will be the our set? So what are the values of x? So x is 1 comma 2 comma 3 comma 4 comma 5 comma 6, and the solution would be a is equal to, what are the values we have? 1 comma 2 comma 3 comma 4 comma 5 comma 6. So this is the rooster format of this statement. Rooster format of this statement. This is the where you have to write the solution. Okay, can we go for next example? So what is the next example? Here, if you observe that, what's the question they have given? Write the set A is equal to 1, comma 4, comma 9, comma 16, so on in set builder form. So they have given roster format here and they are asking us into set builder form. What is set builder form? It is nothing but a statement one. So how can we write it? So let's take A is equal to x is to x is the square of natural number. Okay. Or can we write, we have another option. A is equal to x is to x is equal to n square, where n belongs to z or else g. Okay, both are right. Someone will write like this, someone will write like this. Don't get confusion for both. So both statements are representing the same answer. Okay, if you write any one, it will be correct one only. Let's go to next example. So here itself, if you see the question, it is also asking us to build a set builder form. So what's the condition they have given? They have given a value as 1 by 2, 2 by 3, 3 by 4, so on, 6 by 7. So what if I take 1 by 1 plus 1? I'll get 1 by 2. What if I take 2 by 2 plus 1? I'll get 2 by 3. So from these, shall I write n by n plus 1? If I place one value here, I'll get 1 by 2. 2 value here, I'll get 2 by 3. If I place 3, I'll get 3 by 4 like that, right? So this is the value we have taken as a formula. So A is equal to x is to x is equal to n by n plus 1, where n belongs to capital N. Capital N means it is a natural numbers and n less than or equal to 6. It should not exceed the 7 because they have given up to 6 by 7. If you substitute n value as 6, so you'll get 6 by 6 plus 1, you'll get 6 by 7. This is the way you have to solve the problems. So in our next class, we will start exercise 1.1. Thank you. Thank you for watching.